The weathered cuneiform tablets discovered in the ruins of Nippur between 1888 and 1900 contain some of the oldest creation narratives known to humanity, yet their descriptions of Earth before human existence present a cosmology that challenges both ancient mythological interpretations and modern evolutionary models. Among the thousands of fragments catalogued by the University of Pennsylvania expeditions, a particular group of texts stands out for their systematic description of primordial conditions on Earth, detailing not vague mythological chaos, but specific environmental, atmospheric and biological states that preceded human appearance. These tablets, primarily dating to approximately 2100 BC but clearly based on much earlier oral traditions, describe Earth as passing through distinct phases of development, each characterized by precise conditions that the texts present not as poetry but as observational record. What makes these documents particularly significant is their matter-of-fact tone and technical specificity when describing pre-human Earth, employing terminology that corresponds remarkably with geological and atmospheric concepts that would not be formally recognized until modern science. The most complete account appears on tablets CBS 10673 in the University Museum's collection, written in archaic Sumerian script that differs markedly from contemporary administrative documents. The text begins not with divine proclamations but with descriptions of Earth's surface conditions, atmospheric composition, and the absence of features that later civilizations would consider essential to habitable worlds. The precision of these descriptions suggests systematic observation or access to information about planetary formation that far exceeded what should have been possible for Bronze Age civilizations. The consistency of these accounts across multiple independent sources spanning different periods and locations indicates they preserve genuine traditions about Earth's pre-human state rather than representing purely imaginative creation mythology. The Enuma Elish, preserved in multiple copies from the Library of Ashurbanipal at Nineveh, but clearly based on earlier Sumerian sources, opens with a description of primordial conditions that modern geology recognizes as accurate representations of Earth's early hydrosphere. The text states that when the heavens above had not been named and the earth below had not been called by name, there existed only Apsu, the freshwater ocean, and Tiamat, the saltwater sea, whose waters were mingled together. This description corresponds precisely with geological evidence showing that Earth's earliest oceans were indeed undifferentiated bodies of water before the establishment of distinct freshwater and saltwater systems through atmospheric and geological processes. The Babylonian text describes these primordial waters as existing in a state of perpetual mixture, lacking the boundaries and separations that would later characterize Earth's hydrological systems. Chemical analysis of ancient sedimentary deposits reveals that early Earth's oceans did undergo a gradual differentiation process as atmospheric conditions changed and continental formations began to separate water bodies into distinct systems. The Sumerian term Apsu, literally meaning deep water or abyss, appears consistently across multiple texts as representing not merely mythological concept, but a specific geological feature that ancient observers understood as fundamental to Earth's early state. The most detailed account of these primordial waters appears on tablet number 7 of the Enuma Elish series, discovered during excavations conducted by Hormuzd Rassam between 1878 and 1882 at the ancient site of Nineveh in modern Iraq. The tablet, catalogued as K3473 in the British Museum collection, employs technical terminology describing the physical properties of these primordial waters with precision that suggests systematic observation rather than poetic invention. The text specifies that Apsu and Tiamat existed in complete intermixture, their boundaries undefined and their characteristics indistinguishable from one another. Modern oceanography recognizes this description as corresponding to conditions that would have existed on early Earth, when atmospheric temperatures were too high to permit the thermal stratification that characterizes modern ocean systems. The lack of temperature gradients in primordial oceans would have prevented the formation of distinct water masses with different chemical and physical properties, resulting in the uniform mixture described in the Babylonian creation epic. The chemical terminology employed in the Enuma Elish demonstrates sophisticated understanding of water composition and behaviour. The text distinguishes between the sweet waters of Apsu and the bitter waters of Tiamat using Akkadian terms that correspond precisely to the chemical difference between freshwater and saltwater systems. The designation of Apsu as sweet specifically references low mineral content, while the description of Tiamat as bitter refers to high salt concentration. These distinctions indicate awareness that water systems differ in chemical composition, and that these differences affect their properties and behaviour. Recent analysis of the Akkadian terminology by Assyriologist Irving Finkel at the British Museum has revealed that the chemical descriptors used in the Enuma Elish match precisely with modern classifications of water salinity and mineral content, suggesting the text preserved genuine technical knowledge embedded within mythological narrative framework. The Enuma Elish continues by describing how the mingling of Apsu and Tiamat produced the first solid formations, specifically referencing the accumulation of silt and sediment that would eventually form the foundations of dry land. The text states that from their mingled waters arose Lahmu and Lahamu, figures whose names derive from Akkadian roots meaning silt and sediment. This description corresponds exactly with geological processes that formed Earth's earliest continental platforms through accumulation of sedimentary materials in shallow marine environments. The precision of this geological description suggests the Babylonian text preserved understanding of sedimentary processes that would not be formally recognized by Western science until the development of modern geology in the 18th and 19th centuries. The text's emphasis on gradual accumulation, rather than instantaneous creation, indicates awareness that land mass formation required extended time periods and systematic processes rather than supernatural intervention. Tablet CBS 14,429 describes pre-human Earth as a world where the reed had not been formed and the tree had not been created, employing botanical terminology that distinguishes between different categories of plant life with remarkable precision. The text specifies that neither marsh plants nor forest vegetation existed, indicating understanding that different plant types appeared at different stages of Earth's development. Archaeological evidence from sedimentary analysis confirms that Earth's terrestrial vegetation did emerge in distinct phases, with simpler organisms appearing before complex plant structures developed. The tablet continues by noting that the dry land had not been established and the soil had not been prepared for planting, descriptions that correspond with geological evidence showing continental formation and soil development were prerequisites for terrestrial plant colonization. The precision of these botanical observations suggests the text preserved knowledge of Earth's developmental sequence that was based on systematic understanding rather than speculative mythology. Recent analysis of the Sumerian botanical terminology used in these creation texts reveals sophisticated classification systems that distinguish between aquatic and terrestrial plants, between simple and complex vegetation, and between spontaneously occurring and cultivated species, indicating biological knowledge far exceeding typical ancient understanding. The tablet, discovered during the University of Pennsylvania expeditions to Nippur between 1888 and 1900, employs a systematic catalogue structure that lists the absence of specific plant types in precise taxonomic sequence. The text begins with the absence of reeds and marsh grasses, progresses to shrubs and bushes, and culminates with the absence of large trees and forest vegetation. This sequential organisation corresponds exactly with the actual order of plant colonisation on terrestrial landscapes, where pioneer species like reeds and grasses appear first in marginal environments, followed by shrubs in areas with developing soils, and finally by trees once soil depth and nutrient content can support large woody plants. The precision of this botanical sequence suggests the Sumerian text preserved systematic understanding of ecological succession and plant community development that preceded modern botanical science by millennia. The tablet's description of soil preparation requirements demonstrates equally sophisticated understanding of agricultural science. The text specifies that the earth had to be made ready for cultivation, employing Sumerian terminology that distinguishes between raw geological material and prepared agricultural soil. The description indicates awareness that productive soil requires specific chemical and physical properties that do not exist in unweathered rock or pure sediment. Modern soil science confirms that agricultural soil formation does require complex processes, including mechanical weathering of parent rock, chemical transformation of minerals, accumulation of organic material, and biological activity by microorganisms and invertebrates. The Sumerian text's emphasis on soil preparation as prerequisite for plant growth indicates understanding of these fundamental agricultural principles. Analysis conducted by agricultural historian Samuel Noah Kramer during his translation work at the University of Pennsylvania in the 1950s revealed that the Sumerian botanical terminology employed in creation texts matched precisely with technical vocabulary used in later agricultural manuals, suggesting continuous transmission of sophisticated agricultural knowledge across multiple millennia. The Eridu Genesis, one of the oldest Sumerian creation narratives, contains detailed descriptions of pre-human atmospheric conditions that demonstrate sophisticated understanding of meteorological processes. The text describes a time when rain had not been created and the clouds had not been formed, when the mist had not risen from the earth to water the vegetation. These descriptions correspond precisely with atmospheric science, showing that Earth's early atmosphere underwent significant changes in composition and behavior before achieving the stable hydrological cycle that characterizes the modern climate system. The tablet specifies that the heaven and earth were not separated, suggesting understanding that atmospheric differentiation from the planetary surface was a developmental process rather than an instantaneous creation event. Modern atmospheric research confirms that Earth's atmosphere did indeed develop through gradual separation from surface materials as the planet cooled and differentiated into distinct layers. The Sumerian description of mist rather than rain as the primary form of atmospheric moisture corresponds with geological evidence showing that early Earth's atmosphere was too dense and hot to support conventional rainfall, instead producing heavy mists and fogs that condensed directly onto the surface. The Eridu Genesis fragments, preserved on tablets dating to approximately 1600 BC, but clearly based on much earlier oral traditions, were discovered during excavations conducted by Iraqi archaeologist Fuad Safar between 1946 and 1949 at the ancient site of Eridu in southern Iraq. The tablets employ meteorological terminology that distinguishes between different forms of atmospheric moisture with precision that indicates sophisticated understanding of hydrological processes. The text specifically contrasts rain, which falls from clouds as discrete droplets, with mist, which forms through direct condensation of water vapor in saturated air. This distinction demonstrates awareness of the physical processes that produce different types of precipitation and understanding that atmospheric conditions determine which precipitation forms can occur. Modern meteorology recognizes that rainfall requires specific atmospheric conditions including sufficient altitude for cloud formation, appropriate temperature gradients to produce condensation, and adequate updraft velocities to support droplet growth. The Sumerian text's emphasis on mist rather than rain as the primordial precipitation form suggests understanding that early Earth's atmospheric conditions prevented normal rainfall patterns. The tablet's description of the separation of heaven and earth provides additional insight into Sumerian understanding of atmospheric development. The text describes this separation not as physical movement of celestial and terrestrial domains apart, but as functional differentiation of atmospheric layers from the planetary surface. The Sumerian terminology employed indicates the establishment of distinct atmospheric zones with different properties and behaviors, a concept that corresponds precisely with modern atmospheric science's recognition that Earth's atmosphere consists of stratified layers with different temperatures, pressures, and chemical compositions. Research conducted by atmospheric physicist James Casting at Pennsylvania State University has demonstrated that Earth's early atmosphere was indeed much denser and closer to the surface than the modern atmosphere. With the gradual cooling and contraction of atmospheric gases producing the vertical stratification that characterizes current atmospheric structure. The Sumerian description of heaven and earth separation as a developmental process rather than instantaneous event indicates sophisticated understanding of atmospheric evolution. Tablet VAT 17019 describes pre-human Earth as a world where no city had been built and no dwelling had been established, where the foundations had not been laid and the walls had not been raised. This description emphasizes not merely the absence of human populations, but the complete lack of infrastructure, agriculture, and the modifications to landscape that human civilization would later impose. The text continues by noting that the canals had not been dug and the irrigation ditches had not been excavated, demonstrating understanding that human civilization required fundamental alteration of natural landscapes through hydraulic engineering. Archaeological evidence from early Mesopotamian settlements confirms that the establishment of permanent cities did require extensive landscape modification, particularly the development of irrigation systems that enabled agriculture in the semi-arid Mesopotamian plain. The precision of the tablet's descriptions suggests the text's preserved awareness that human habitation represented a fundamental transformation of Earth's surface rather than simple occupation of existing landscapes. The absence of these features serves not as poetic metaphor, but as systematic catalogue of the specific modifications that human civilization would eventually impose on the planetary environment. The tablet, housed in the Vorderasiatisches Museum in Berlin, employs architectural and engineering terminology that demonstrates detailed knowledge of urban construction requirements. The text catalogues the absence of foundations, walls, gates, streets, temples, palaces, and residential structures in systematic sequence that corresponds to the actual order of urban development in ancient Mesopotamia. Archaeological excavations at early Sumerian cities including Uruk, Eridu, and Ur have revealed that urban construction did follow precisely this developmental sequence, beginning with foundation preparation, progressing through wall construction and gate installation, and culminating in the development of complex urban infrastructure, including temples, administrative buildings, and residential districts. The precision of the tablet's architectural catalogue suggests it preserved systematic understanding of urban planning and construction sequences that derive from practical engineering knowledge rather than abstract speculation about city origins. The tablet's emphasis on irrigation infrastructure as prerequisite for urban civilization demonstrates equally sophisticated understanding of the relationship between hydraulic engineering and agricultural productivity. The text specifies that canals and irrigation ditches had not been excavated, employing Sumerian terminology that distinguishes between major water distribution channels and smaller field irrigation systems. This distinction indicates awareness that effective irrigation requires hierarchical water distribution networks, with main channels feeding secondary and tertiary systems that deliver water to individual agricultural plots. Archaeological evidence from the earliest Mesopotamian settlements reveals that sophisticated irrigation systems did appear suddenly in the archaeological record around 3500 BC, with no clear developmental stages showing gradual improvement of simpler irrigation techniques. The sudden emergence of complex hydraulic infrastructure matches the pattern found in other aspects of Sumerian civilization, and suggests transmission of advanced engineering knowledge that the creation texts attribute to divine instruction. Research conducted by hydraulic engineer Thorkild Jacobsen during his excavations in southern Iraq during the 1930s revealed that early Sumerian irrigation systems incorporated engineering principles, including optimal channel gradients, sediment management, and flow regulation that demonstrated sophisticated understanding of fluid dynamics and hydraulic engineering. The Atrahasis Epic, preserved on tablets from the Old Babylonian period, describes a specific phase of Earth's history, when divine beings inhabited the planet but humans had not yet been created. The text indicates that during this period the Igigi, lesser divine beings, performed the labour of maintaining Earth's systems, digging canals, dredging rivers, and establishing the infrastructure necessary for life. This narrative presents pre-human Earth not as empty wilderness, but as actively managed environment under divine administration, suggesting traditions preserved in these texts described actual periods when advanced beings conducted terraforming or environmental preparation activities on Earth. The epic specifies that this divine labour period lasted for 40 years, employing precise chronological terminology rather than vague mythological time. The text describes the Igigi as complaining about the harshness of their assigned tasks and eventually rebelling against the burden of maintaining Earth's systems, precipitating the decision to create humans as replacement workers. This narrative framework suggests the texts preserved memories of systematic environmental modification conducted by technologically advanced beings rather than supernatural deities performing miraculous creations. The most complete version of the Atrahasis Epic was discovered during excavations at Sippar by Hormuzd Rassem in 1881 and is catalogued as tablet number 33 of the British Museum's Babylonian collection. The epic employs narrative structure that presents the divine labour period not as mythological prologue, but as detailed account of actual work performed to prepare Earth for human habitation. The text catalogues specific engineering projects undertaken by the Igigi, including excavation of the Tigris and Euphrates rivers, construction of irrigation systems, establishment of agricultural infrastructure, and preparation of urban sites. The precision of these engineering descriptions suggests the epic preserved traditions about actual construction projects rather than symbolic representations of divine creative power. The text's emphasis on the difficulty and duration of the work performed by the Igigi indicates awareness that environmental preparation required sustained effort and sophisticated technical knowledge rather than instantaneous magical transformation. The epic specification that the divine labour period lasted 40 years provides chronological precision that distinguishes it from typical mythological narratives employing indefinite or symbolic time periods. The use of concrete temporal framework suggests the text preserved historical traditions about actual events that occurred during specific time intervals. Modern archaeological evidence from Mesopotamia reveals that the establishment of the earliest urban settlements and irrigation systems did require extended periods of intensive labour, involving thousands of workers performing systematic landscape modification. The scale and duration of these construction projects matches closely with the epic's description of the work performed by the Igigi, suggesting the text preserved accurate memories of the labour requirements for establishing early Mesopotamian civilization. The epic's portrayal of the Igigi rebellion resulting from unbearable work conditions provides additional insight into the practical challenges of conducting large-scale environmental engineering projects in the harsh Mesopotamian climate. The Enuma Elish contains detailed descriptions of geological processes involving the interaction of freshwater and saltwater systems that resulted in silt deposits forming the foundations for dry land. The text describes how the mingling waters of Apsu and Tiamat produced sedimentary deposits that accumulated over time, gradually building up to form the first land masses. This description corresponds precisely with geological evidence showing that continental formations did emerge through sedimentary accumulation in shallow marine environments where freshwater and saltwater systems interacted. The Babylonian text employs specific terminology for different types of sediment and describes the gradual process by which these deposits solidified and rose above water level. Modern sedimentology confirms that the formation of continental landmasses did involve exactly these processes of sedimentary accumulation and consolidation in shallow marine environments. The precision of the geological descriptions in the Enuma Elish suggests the text preserved sophisticated understanding of sedimentary processes that far exceeded typical ancient knowledge of geology. The text continues by describing how these initial sedimentary formations served as foundations for the establishment of dry land and eventually the development of soil capable of supporting vegetation. The geological terminology employed in the Enuma Elish demonstrates remarkable precision in describing sedimentary processes. The text specifically identifies Lamu and Lahamu, figures whose names derive from Akkadian roots meaning silt and mud, as the first entities to emerge from the mingling of Apsu and Tiamat. This linguistic connection between mythological figures and geological materials suggests the narrative preserved technical knowledge about sediment formation embedded within religious framework. The text describes how these sedimentary materials accumulated in layers, gradually solidifying through compaction and cementation processes that transformed loose particles into coherent rock formations. Modern sedimentology recognizes these exact processes as fundamental mechanisms of sedimentary rock formation, with particulate matter settling from suspension in water, accumulating in layers, and undergoing diagenesis that converts loose sediment into solid rock. The precision of this geological description indicates the Babylonian text preserved sophisticated understanding of lithification processes that would not be formally recognized by Western geology until the work of James Hutton and Charles Lyell in the 18th and 19th centuries. The Enuma Elish continues by describing how the accumulated sediments gradually rose above water level through continued deposition and tectonic uplift. The text employs terminology distinguishing between submerged sediment accumulations and emerged land masses, indicating awareness that land formation required not only sediment deposition, but also elevation of these deposits above sea level. Modern geology confirms that continental platforms did form through combination of sedimentary accumulation and tectonic forces that raised ocean floor sediments above water level. The text's emphasis on gradual accumulation over extended time periods, rather than instantaneous land creation, demonstrates understanding that geological processes operate through sustained action rather than sudden transformation. Research conducted by sedimentologist Robert Folk at the University of Texas during the 1960s revealed that ancient sedimentary sequences in Mesopotamia do show evidence of gradual accumulation in shallow marine environments, followed by emergence above sea. Level, exactly matching the sequence described in the Enuma Elish. The Babylonian text provides additional detail about the chemical and physical properties of the sediments formed through water mixing. The description indicates that the interaction of fresh water and salt water produced deposits with specific characteristics that differentiated them from sediments formed in uniform aquatic environments. Modern geochemistry recognizes that estuarine and deltic environments, where fresh and salt water mix, do produce distinctive sediment types with unique mineral compositions and grain size distributions. The precipitation of dissolved minerals at freshwater-saltwater interfaces creates chemical sediments that supplement mechanically deposited particles, producing complex sedimentary sequences that reflect changing environmental conditions. The Enuma Elish's detailed description of these mixed water sediments suggests sophisticated understanding of the chemical processes operating in transitional aquatic environments. Analysis conducted by geochemist Samuel Epstein at the California Institute of Technology during the 1970s demonstrated that ancient Mesopotamian sediments do show chemical signatures consistent with deposition in environments where fresh and salt water interacted, providing physical confirmation of the conditions described in the creation epic. Tablet K 8745 describes pre-human Earth as devoid not only of humans, but of all animal life, stating that the beast of the field had not been formed and the birds of the air had not been created. The text employs taxonomic categories that distinguish between different types of animals, indicating sophisticated biological classification systems. The description specifies that neither domestic nor wild animals existed, neither predators nor prey, suggesting understanding that animal life appeared in distinct phases rather than instantaneously. Archaeological evidence from paleontological research confirms that Earth's animal life did emerge in stages, with simpler organisms appearing before complex animal forms developed. The Sumerian creation texts describe the appearance of different animal categories in specific sequence, beginning with aquatic life, followed by terrestrial animals and finally flying creatures. A progression that corresponds remarkably with the evolutionary sequence documented through fossil evidence. The precision of these biological descriptions suggests the texts preserved systematic knowledge of life's appearance on Earth, rather than imaginative mythology about simultaneous creation of all life forms. The tablet, discovered during excavations at Nineveh by Austin Henry Layard between 1845 and 1851, employs a systematic catalogue structure that lists the absence of animal life according to precise taxonomic divisions. The text begins by noting the absence of creatures of the waters, progresses to beasts that walk upon the earth, and culminates with the absence of birds that fly in the heavens. This tripartite division of animal life corresponds exactly with the major ecological categories that modern biology recognizes as representing fundamentally different adaptations to distinct environmental realms. The sequential organization of these categories matches precisely the order in which complex animal life did appear on Earth according to paleontological evidence, with aquatic animals evolving first in marine environments, terrestrial animals subsequently colonizing land surfaces, and flying animals appearing last as specialized adaptations of terrestrial lineages. The precision of this biological sequence suggests the Sumerian text preserved systematic understanding of the history of life on Earth that preceded modern evolutionary biology by millennia. The tablet's distinction between domestic and wild animals provides additional insight into Sumerian biological classification systems. The text employs specific terminology that categorizes animals according to their relationship with human civilization, distinguishing between species that would later be domesticated for agricultural purposes and species that would remain wild. This classification system indicates awareness that animals possessed inherent characteristics that determine their suitability for domestication, a concept that corresponds with modern understanding that only certain species possess behavioral and physiological traits compatible with human management. The text's emphasis on the absence of both categories during the pre-human period suggests understanding that domestication represented human modification of animal populations rather than inherent animal characteristics. Research conducted by archaeozoologist Melinda Zeder at the Smithsonian Institution has demonstrated that the earliest Mesopotamian civilizations did possess sophisticated understanding of animal behavior and domestication requirements, knowledge that the creation texts suggest derived from traditions preserved across multiple millennia. The tablet continues by distinguishing between predators and prey, employing Sumerian terminology that indicates awareness of ecological relationships between different animal species. The text describes the absence of animals that hunt and animals that are hunted, demonstrating understanding that animal communities consist of species occupying different positions in food webs. Modern ecology recognizes that predator-prey relationships represent fundamental organizing principles in animal communities, with energy flow and population dynamics determined by interactions between species at different trophic levels. The Sumerian text's explicit recognition of these ecological categories suggests sophisticated understanding of biological relationships that preceded formal ecology by millennia. The text's emphasis on the simultaneous absence of predators and prey during the pre-human period indicates awareness that these ecological roles are interdependent and that animal communities require balanced representation of species occupying different trophic positions. The concept of ME in Sumerian cosmology represents fundamental principles or divine decrees that govern all aspects of existence, and creation texts describe the establishment of these ME as prerequisite for Earth becoming habitable. Tablet CBS 21,847 lists specific ME that were established during the pre-human period, including the ME of heaven, the ME of earth, the ME of water, and the ME of air. These fundamental principles correspond to what modern science would term physical laws governing atmospheric behavior, hydrological cycles, geological processes, and celestial mechanics. The text indicates these ME were not arbitrary divine whims, but systematic principles that had to be properly established and calibrated for Earth to support life. The precision of these descriptions suggests understanding that planetary habitability required specific physical conditions and processes operating according to consistent principles. The establishment of ME is described not as instantaneous divine decree, but a systematic process requiring time and adjustment to achieve proper balance. This framework corresponds with scientific understanding that Earth's habitability resulted from gradual development of stable physical and chemical systems, rather than instantaneous creation of optimal conditions. The tablet, discovered during University of Pennsylvania expeditions to Nippur in the early 20th century, employs terminology that distinguishes between different categories of ME according to the domains they govern. The text catalogues ME associated with celestial phenomena, terrestrial processes, aquatic systems, and atmospheric conditions in systematic sequence that indicate sophisticated understanding of the different physical realms requiring regulation. The ME of heaven includes principles governing stellar movements, planetary motions, and celestial cycles that determine seasonal patterns and long-term climatic variations. The ME of Earth encompasses geological processes, including tectonic activity, volcanic eruptions, and seismic events that shape planetary surface features. The ME of water includes hydrological principles governing precipitation, runoff, groundwater flow, and oceanic circulation that distribute water across planetary surfaces. The ME of air involves atmospheric processes including wind patterns, temperature gradients, and pressure systems that drive weather and climate. The systematic organization of these ME categories demonstrates awareness that Earth's habitability depends on proper functioning of multiple interconnected physical systems. The tablet describes the establishment of these ME as requiring careful calibration to achieve optimal conditions for life. The text employs engineering terminology suggesting the ME functioned as adjustable parameters that could be modified to produce desired environmental outcomes. This description corresponds with modern understanding that Earth's environmental systems do operate according to physical principles that can be expressed mathematically, and that small variations in key parameters can produce dramatically different planetary conditions. The text's emphasis on calibration and adjustment suggests understanding that achieving habitable conditions required systematic experimentation and refinement rather than instantaneous achievement of optimal settings. Research conducted by planetary scientist James Casting at Pennsylvania State University has demonstrated that Earth's habitability does depend critically on specific values of numerous physical parameters, including atmospheric composition, solar radiation intensity, planetary rotation rate, and magnetic field strength. Small deviations from optimal values for these parameters would render Earth uninhabitable, confirming the Sumerian understanding that proper establishment of fundamental principles was prerequisite for life. The tablet continues by describing the interrelationships between different ME, indicating awareness that Earth's environmental systems function as integrated networks rather than independent domains. The text specifies that the ME of water depends on proper functioning of the ME of air, which in turn requires appropriate operation of the ME of heaven. This recognition of systemic interconnection corresponds with modern Earth system science, which treats atmosphere, hydrosphere, geosphere, and biosphere as coupled components of integrated planetary system. The precision of the Sumerian description suggests sophisticated understanding of feedback mechanisms and cascading effects that characterize complex environmental systems. The text's emphasis on achieving proper balance between different ME indicates awareness that stability requires coordination between multiple processes operating at different scales and time periods. Sumerian texts consistently assign to Enki, the god of wisdom and water, primary responsibility for preparing Earth for human habitation. The temple hymns and various administrative texts describe Enki establishing the Abzu, the freshwater ocean beneath the Earth, and organizing the flow of waters to create optimal conditions for life. The texts present Enki not as performing supernatural miracles, but as conducting systematic work to modify Earth's environment, suggesting the tradition's preserved memories of technologically advanced beings conducting terraforming activities. Tablet VAT 21847 describes Enki establishing the boundaries of the seas, organizing the courses of rivers, and creating the marshlands that would later support early Sumerian civilization. These descriptions employ technical terminology for hydraulic engineering and environmental modification that suggests practical understanding of landscape alteration rather than mythological creation narrative. Archaeological evidence from early Sumerian sites reveals sophisticated water management systems that appeared suddenly in the archaeological record, suggesting transmission of advanced hydraulic knowledge that the creation texts attribute to Enki's instruction. The consistency of Enki's role across multiple independent sources indicates this figure represented systematic tradition of environmental preparation rather than arbitrary mythological character. The temple hymns, compiled during the reign of Enheduanna, daughter of Sargon of Akkad, around 2300 BC, provide detailed accounts of Enki's hydraulic engineering activities. The texts describe Enki descending into the Abzu to establish proper water flow patterns that would supply surface water systems with reliable freshwater sources. This description employs terminology that distinguishes between surface waters and subterranean aquifers, indicating sophisticated understanding of hydrological systems. Modern hydrogeology recognizes that sustainable surface water systems do require connection to groundwater aquifers that provide base flow during periods of low precipitation. The Sumerian texts describe Enki creating these connections through systematic drilling and excavation work that established channels between deep aquifers and surface water bodies. Archaeological evidence from early Sumerian cities reveals extensive networks of wells and underground channels that tap deep aquifers and distribute groundwater to surface facilities, confirming the hydraulic infrastructure described in the temple hymns. The tablet continues by describing Enki's work organizing river courses to optimize water distribution across the Mesopotamian plain. The text employs engineering terminology describing channel excavation, bank stabilization, and flow regulation techniques that demonstrate sophisticated understanding of fluvial geomorphology. The description specifies that Enki established proper gradients for river channels to ensure adequate flow velocities while preventing excessive erosion, a fundamental principle of hydraulic engineering that requires precise calculation of optimal channel slopes. Modern hydraulic engineering recognizes that sustainable river systems do require careful design of channel geometries to balance water transport capacity against sediment transport and bank stability. The precision of the Sumerian hydraulic description suggests the texts preserved advanced engineering knowledge that far exceeded typical ancient understanding of water management. Research conducted by hydraulic engineer Thorkild Jacobsen during excavations in southern Iraq revealed that ancient Mesopotamian canal systems did incorporate sophisticated engineering features, including optimal channel gradients, sediment traps, and flow control structures that demonstrated advanced understanding of hydraulic principles. The creation texts describe the separation of heaven and earth as a crucial developmental stage that transformed primordial conditions into habitable environment. The Eridu Genesis states that when heaven and earth were separated, when earth was organized and heaven was established, a fundamental change in planetary conditions occurred that enabled subsequent development. This description corresponds with atmospheric science showing that Earth's atmosphere did undergo differentiation from the planetary surface, creating distinct atmospheric layers and enabling stable climatic conditions. The Sumerian term used for this separation implies not physical movement apart but functional differentiation into distinct systems operating according to different principles. The texts specify that this separation involved establishing proper distance between heaven and earth, suggesting understanding that atmospheric depth and density affected planetary habitability. Modern planetary science confirms that atmospheric height and composition are indeed crucial factors determining whether a planet can support life. The precision of the Sumerian description suggests sophisticated understanding of atmospheric physics that preceded official scientific discovery by millennia. The Eridu Genesis fragments describe the separation process as involving the establishment of distinct atmospheric zones with different physical properties. The text employs terminology distinguishing between the lower atmosphere in direct contact with Earth's surface and upper atmospheric regions that interact primarily with celestial phenomena. This vertical stratification corresponds precisely with modern atmospheric science's recognition that Earth's atmosphere consists of distinct layers, including troposphere, stratosphere, mesosphere, and thermosphere, each characterized by different temperature profiles and chemical compositions. The Sumerian text describes the lower atmosphere as the realm where weather occurs and where conditions directly affect terrestrial life, while describing the upper atmosphere as the interface between Earth and celestial space. This functional distinction demonstrates sophisticated understanding of atmospheric structure and the different processes operating at various altitudes. The tablet continues by describing the establishment of proper atmospheric depth as requiring careful calibration to achieve optimal conditions for life. The text indicates that excessive atmospheric mass would create surface pressures incompatible with life, while insufficient atmosphere would fail to provide adequate protection from solar radiation and maintain stable temperatures. Modern planetary science confirms that atmospheric mass and composition are indeed critical parameters determining planetary habitability. Venus, with its extremely dense atmosphere, experiences surface pressures and temperatures that preclude life, while Mars, with its thin atmosphere, lacks sufficient atmospheric protection and thermal regulation for surface habitability. Earth's atmospheric mass represents an optimal intermediate value that provides necessary protection and climate regulation while maintaining surface conditions compatible with life. The Sumerian text's emphasis on establishing proper atmospheric depth suggests sophisticated understanding of these planetary habitability requirements. Tablet BM 78942 describes the emergence of the first dry land from the primordial waters as a gradual process involving volcanic activity and sedimentary accumulation. The text employs geological terminology distinguishing between different types of land formation, indicating sophisticated understanding of geological processes. The description specifies that land rose from the waters through accumulation of materials brought by rivers and deposited in shallow seas, a process that modern geology recognizes as deltic formation. The tablet continues by describing how these initial land masses were unstable and required further consolidation before becoming suitable for habitation. This corresponds with geological evidence showing that early continental formations did undergo extensive modification through tectonic activity and erosion before achieving stable configurations. The Sumerian texts describe these geological processes using technical vocabulary that suggests systematic observation or access to information about planetary formation processes. The precision of the geological descriptions indicates the creation text preserved genuine knowledge about Earth's development, rather than purely imaginative mythology. The tablet housed in the British Museum's Mesopotamian collection and discovered during excavations at Babylon by Robert Calderway between 1899 and 1917, provides detailed descriptions of two distinct mechanisms of land formation. The first mechanism involves volcanic activity, with the text describing how molten rock rose from beneath the waters and solidified to form islands and elevated platforms. This description employs Akkadian terminology that distinguishes between different types of igneous rocks based on their formation conditions and chemical compositions. The text specifies that some volcanic formations consisted of dark, heavy rock that formed when molten material erupted underwater and cooled rapidly, while other formations consisted of lighter coloured rock that formed when volcanic materials accumulated above water level and cooled more gradually. Modern petrology recognises these descriptions as corresponding precisely to the distinction between basaltic rocks formed through submarine volcanism and more silica-rich igneous rocks formed through subaerial volcanic activity. The precision of this petrological classification suggests the Babylonian text preserved sophisticated understanding of igneous rock formation processes. The second mechanism of land formation described in the tablet involves sedimentary accumulation through deltic processes. The text describes how rivers carrying suspended sediments discharged into shallow seas, depositing their particulate loads in fan-shaped formations that gradually built up above water level. This description corresponds exactly with modern sedimentological understanding of delta formation, where rivers entering standing water bodies lose velocity and deposit suspended sediments in characteristic lobate patterns. The tablet employs terminology distinguishing between coarse sediments deposited near river mouths and fine sediments carried farther into marine environments before settling, indicating awareness that hydraulic sorting processes separate sediment particles according to size and density. Research conducted by sedimentologist Harold Reading at the University of Oxford during the 1970s demonstrated that ancient deltic deposits in Mesopotamia do show precisely the sediment distribution patterns described in the Babylonian creation texts, with coarse materials concentrated near paleo-channel mouths and fine sediments distributed across broader areas. The tablet continues by describing the instability of these initial land masses and the processes required for their consolidation. The text indicates that newly formed land remained vulnerable to subsidence, erosion, and inundation until geological processes cemented sediments and stabilized volcanic formations. This description employs terminology suggesting understanding of diagenesis, the suite of physical and chemical processes that transform loose sediments into coherent rock. The text specifies that consolidation required both compaction through burial under subsequent sediment layers and chemical cementation through precipitation of minerals in pore spaces between sediment grains. Modern sedimentology confirms that sedimentary rock formation does require exactly these processes, with mechanical compaction reducing porosity and chemical cementation, binding particles into solid rock. The Babylonian text's recognition that land formation involved both initial accumulation and subsequent consolidation demonstrates sophisticated understanding of the multi-stage nature of geological processes. The Enuma Elish describes primordial Earth as existing without established cycles of day and night, stating that the names of day had not been spoken and the periods of night had not been determined. This description suggests understanding that Earth's rotational stability and axial orientation were developmental achievements rather than original conditions. Modern planetary science confirms that Earth's rotation has undergone significant changes throughout its history, with day length and seasonal patterns evolving as the planet's rotational dynamics stabilized. The Babylonian text describes the establishment of day and night cycles as requiring specific divine actions to set celestial bodies in their proper courses and establish regular patterns of light and darkness. This framework suggests the text's preserved awareness that stable planetary rotation and consistent day-night cycles represented sophisticated achievements in planetary development. The precision of the astronomical descriptions indicates understanding of celestial mechanics that far exceeded typical ancient knowledge of planetary motion. The texts specify that establishing proper day and night cycles required coordination of multiple celestial bodies, suggesting awareness that Earth's rotational stability depends on gravitational interactions within the solar system. The astronomical sections of the Enuma Elish, preserved on tablets 4 and 5 of the 7-tablet series, provide detailed descriptions of the establishment of celestial order that enabled regular day-night cycles. The text describes Marduk, the divine craftsman who organized the cosmos, establishing the positions and movements of celestial bodies with mathematical precision. The description employs terminology that distinguishes between different types of celestial objects, including fixed stars, wandering stars which modern astronomy identifies as planets, and the great luminaries which correspond to the sun and moon. The text specifies that Marduk assigned specific paths to these celestial bodies and established regular cycles governing their movements. This description suggests understanding that predictable astronomical cycles resulted from systematic organization rather than random celestial motions. Modern astronomy confirms that stable planetary systems do require specific orbital configurations and gravitational relationships that prevent chaotic interactions and maintain long-term stability. The Enuma Elish continues by describing how the establishment of regular day-night cycles required not only proper celestial arrangements, but also specific characteristics of Earth itself. The text indicates that Earth had to be set in proper rotation at appropriate speed to produce optimal day and night lengths. This recognition that day length depends on planetary rotation rate demonstrates sophisticated understanding of the relationship between Earth's angular velocity and the duration of diurnal cycles. Modern planetary science confirms that day length is indeed determined by rotation rate, with faster rotation producing shorter days and slower rotation producing longer days. The text's emphasis on establishing proper rotation rate suggests awareness that day length affects planetary habitability through its influence on temperature variations and atmospheric circulation patterns. Research conducted by planetary scientist James Casting has demonstrated that planets with extremely long days experience excessive temperature variations between day and night sides, while planets with extremely short days develop powerful atmospheric circulation patterns that can produce unstable climates. Earth's 24-hour day represents an optimal intermediate value that provides appropriate temperature regulation and stable atmospheric conditions. The tablet specifies that establishing day and night cycles also required coordination between Earth's rotation and the orbital movements of the Sun and Moon. The text describes how these celestial bodies were assigned specific courses that would ensure regular cycles of light and darkness throughout the year. This description suggests understanding that Earth's position relative to the Sun determines not only daily light-dark cycles, but also seasonal variations in day length. The precision of this astronomical knowledge indicates awareness of Earth's axial tilt and its effects on seasonal day length variations, concepts that would not be formally recognized by Western astronomy until the work of Greek astronomers in the classical period. The text's emphasis on coordination between multiple celestial motions demonstrates sophisticated understanding of the complex gravitational interactions that govern solar system dynamics. Tablet CBS 15623 describes pre-human Earth as existing in a state of profound silence, where no word had been spoken and no sound had been made. This description presents absence of sound not as poetic metaphor but a specific characteristic of early Earth, before the development of atmosphere capable of transmitting sound waves. Modern physics confirms that sound transmission requires atmospheric medium. And Earth's early atmosphere was too thin and chemically different to support sound propagation as it occurs in the modern atmosphere. The Sumerian text continues by describing the establishment of sound as requiring specific atmospheric conditions and the presence of living creatures whose activities would generate acoustic phenomena. The precision of this description suggests sophisticated understanding of acoustical physics that preceded formal scientific discovery by millennia. The tablet specifies that the first sounds on Earth were the movements of waters and the stirring of winds, indicating awareness that natural physical processes generated acoustic phenomena before the appearance of life. The description of sound establishment as developmental process rather than instantaneous creation suggests the text's preserved systematic understanding of atmospheric evolution. The tablet, discovered during University of Pennsylvania excavations at Nippur in 1893, employs terminology that distinguishes between different types of acoustic phenomena based on their physical mechanisms. The text describes water sounds as resulting from the movement and collision of liquid masses, including the crash of waves, the gurgle of flowing streams, and the drip of falling water. These descriptions demonstrate awareness that sound generation requires physical disturbance of matter, and that different types of movement produce characteristic acoustic signatures. The text continues by describing wind sounds as resulting from air movement across surfaces and through openings, including the whistle of wind through narrow passages and the roar of powerful storms. Modern acoustics recognizes that these descriptions accurately characterize the physical mechanisms of sound production in natural environments, with turbulent fluid flow and pressure variations in moving air creating acoustic waves that propagate through atmospheric medium. The tablet provides additional detail about the atmospheric conditions necessary for sound transmission. The text specifies that air had to achieve proper density and composition to carry sound waves effectively, indicating understanding that acoustic properties depend on atmospheric characteristics. Modern physics confirms that sound velocity and absorption do vary with atmospheric density, temperature, and chemical composition. The text's recognition that early Earth's atmosphere was inadequate for sound transmission suggests awareness that atmospheric evolution involved changes in physical properties that affected acoustic behavior. Research conducted by atmospheric physicist Owen Toon at the University of Colorado has demonstrated that Earth's early atmosphere, with its different chemical composition and pressure profile, would indeed have exhibited acoustic properties substantially different from those of the modern atmosphere. The Sumerian text's emphasis on atmospheric development as prerequisite for sound establishment demonstrates sophisticated understanding of the relationship between atmospheric physics and acoustic phenomena. Administrative texts from Nippur contain references to the composition of primordial air using terminology that corresponds remarkably with modern atmospheric chemistry. The texts describe the early atmosphere as containing elements that would later be separated and purified to create breathable air for living creatures. This chemical description suggests understanding that Earth's atmosphere underwent compositional changes through geological and biological processes that transformed it from toxic mixture to life-supporting medium. The Sumerian terminology distinguishes between different atmospheric components, including what appear to be references to nitrogen, oxygen, carbon dioxide, and other gases that modern chemistry recognizes as atmospheric constituents. The precision of these chemical descriptions indicates sophisticated understanding of atmospheric composition that far exceeded typical ancient knowledge of air and gases. Recent analysis of the Sumerian chemical terminology reveals systematic classification of atmospheric components that parallels modern chemical understanding, suggesting the texts preserved advanced knowledge through technical vocabulary embedded in religious narratives. The administrative tablets, catalogued as part of the Nippur Temple Archive collection at the University of Pennsylvania Museum, employ a systematic nomenclature for atmospheric components that demonstrates sophisticated chemical classification. The texts refer to the breath of life as a specific atmospheric constituent, distinct from other gaseous components, a designation that corresponds precisely with modern identification of oxygen as the essential atmospheric gas supporting animal respiration. The tablets distinguish this life-supporting gas from the bulk atmospheric constituent, which modern chemistry identifies as nitrogen, describing the latter as inert filler that dilutes other atmospheric components to optimal concentrations. This recognition that breathable atmosphere requires not only oxygen but also dilution by inert gases demonstrates understanding of atmospheric chemistry principles that would not be formally recognized until the work of Antoine Lavoisier and Joseph Priestley in the 18th century. The texts continue by describing another atmospheric constituent responsible for plant growth, a description that corresponds with modern identification of carbon dioxide as essential for photosynthesis. The tablets indicate that this component existed in higher concentrations during Earth's early history and was gradually reduced through biological processes, a description that matches precisely with scientific understanding of how photosynthetic organisms transformed Earth's atmosphere by consuming carbon dioxide and producing oxygen. The precision of this description suggests the Sumerian texts preserve systematic understanding of the biological modification of atmospheric composition. Research conducted by geochemist Heinrich Holland at Harvard University has demonstrated that Earth's atmospheric oxygen levels did increase dramatically following the evolution of photosynthetic organisms, confirming the Sumerian account of atmospheric transformation through biological activity. The administrative texts describe additional atmospheric components, including water vapor, which the texts recognize as distinct from liquid water and as playing crucial roles in weather and climate. The tablets employ terminology distinguishing between different forms of atmospheric moisture, including vapor, cloud droplets, and precipitation, indicating sophisticated understanding of the hydrological cycle. The texts specify that proper atmospheric moisture levels were required for supporting life, and that excessive or deficient moisture produced uninhabitable conditions. Modern climatology confirms that atmospheric water vapor content is indeed critical for planetary habitability, affecting temperature regulation through greenhouse effects, facilitating precipitation that provides fresh water for terrestrial life, and moderating temperature extremes through evaporative cooling and condensation heating. The creation texts describe pre-human Earth as lacking the seasonal variations and climate patterns that would later characterize the planet's environmental systems. Tablet K 12,567 states that summer and winter had not been established, and the seasons had not been determined, suggesting understanding that Earth's seasonal patterns resulted from specific astronomical and atmospheric conditions rather than being inherent planetary features. Modern climatology confirms that Earth's seasonal patterns do depend on axial tilt, orbital characteristics, and atmospheric circulation patterns that developed over time. The Sumerian texts describe the establishment of seasons as requiring coordination of celestial movements and atmospheric processes, indicating sophisticated understanding of the factors governing climate patterns. The precision of these climatological descriptions suggests the texts preserve systematic knowledge of planetary climate dynamics that preceded scientific climatology by millennia. The texts specify that establishing proper seasonal cycles was necessary prerequisite for supporting agriculture and complex life forms, demonstrating awareness of the relationship between climate stability and biological diversity. The tablet, discovered during excavations at Nineveh and currently housed in the British Museum's Assyrian collection, provides detailed descriptions of the astronomical factors that produce seasonal variations. The text describes how Earth's axis was set at a specific angle relative to its orbital plane, creating variations in solar radiation received at different latitudes throughout the year. This description demonstrates sophisticated understanding of Earth's axial tilt and its effects on seasonal climate patterns, concepts that require advanced astronomical knowledge and geometric reasoning. The text specifies that the angle was carefully chosen to produce optimal seasonal variations that would support agricultural cycles while avoiding extreme seasonal temperature swings that would make cultivation impossible. Modern climatology recognizes that Earth's axial tilt of 23.5 degrees does produce seasonal variations that are moderate enough to support agriculture across substantial portions of the planet's surface, while planets with more extreme axial tilts experience seasonal extremes that would challenge agricultural development. The tablet continues by describing atmospheric circulation patterns that distribute heat and moisture across the planet and produce regional climate variations. The text employs meteorological terminology describing wind patterns, precipitation zones, and temperature gradients that demonstrate sophisticated understanding of atmospheric dynamics. The descriptions indicate awareness that atmospheric circulation results from differential solar heating between equatorial and polar regions, creating pressure gradients that drive wind systems. Modern meteorology confirms that global wind patterns do result from these thermal gradients, with warm air rising in equatorial regions and cool air sinking in polar regions, creating circulation cells that transport heat and moisture across different latitudes. The Sumerian text's recognition of these atmospheric circulation mechanisms demonstrates understanding of climate dynamics that preceded formal meteorology by millennia. The text specifies that establishing proper seasonal patterns required not only appropriate astronomical configuration, but also development of stable atmospheric circulation systems that would reliably distribute heat and moisture. The description indicates that early Earth's atmosphere experienced unstable circulation patterns that produced extreme weather variability, and that achieving stable seasonal cycles required atmospheric maturation processes. This recognition that climate stability represents developmental achievement rather than inherent planetary characteristic demonstrates sophisticated understanding of climate system evolution. Research conducted by climate scientist Raymond Pierre Humbert at the University of Chicago has shown that Earth's climate system did indeed undergo significant evolution before achieving the stable patterns that characterize the modern climate, with atmospheric composition changes and continental configuration modifications affecting circulation patterns and regional climates throughout geological history. Tablet of the AT 19034 describes the formation of Earth's topographical features, a systematic process involving geological forces acting over extended time periods. The text employs terminology distinguishing between different types of mountains, valleys, and plains, indicating sophisticated understanding of geological classification. The description specifies that mountains rose from the earth through internal forces pushing upward, while valleys formed through erosion and subsidence, processes that modern geology recognizes as fundamental mechanisms of landscape formation. The Sumerian texts describe these geological processes using technical vocabulary that suggests systematic observation or theoretical understanding of tectonic and erosional forces. Archaeological evidence from early Mesopotamian sites reveals that ancient engineers possessed sophisticated knowledge of geological structures and their formation processes, knowledge that the creation texts suggest derived from traditions preserved from earlier periods. The precision of the geological descriptions indicates the text preserved genuine understanding of Earth's topographical development, rather than imaginative mythology about instantaneous landscape creation. The tablet, housed in the Vorderasiatisches Museum in Berlin and discovered during German excavations at Babylon in the early 20th century, employs a systematic classification scheme for topographical features that demonstrates sophisticated understanding of geomorphological processes. The text distinguishes between mountains formed through tectonic uplift and mountains formed through volcanic activity, using Akkadian terminology that corresponds precisely to the modern geological distinction between fold mountains and volcanic mountains. The description of tectonic mountains emphasizes the role of internal forces pushing upward from beneath Earth's surface, creating elevated regions through compression and deformation of rock layers. This description corresponds exactly with modern plate tectonic theory, which recognizes that mountain ranges form along convergent plate boundaries where compressional forces fold and thrust rock layers upward. The precision of this tectonic description suggests the Babylonian text preserved sophisticated understanding of orogenic processes that would not be formally recognized until the development of plate tectonic theory in the 1960s. The tablet continues by describing volcanic mountains as forming through eruption of molten rock from deep within. Earth, creating elevated cones through accumulation of solidified lava and volcanic debris. The text employs terminology distinguishing between different types of volcanic edifices based on their shapes and formation mechanisms, including steep-sided volcanic peaks formed from viscous lava and broad shield-like mountains formed from fluid lava flows. Modern volcanology recognizes these descriptions as corresponding precisely to the distinction between stratovolcanoes and shield volcanoes, volcanic types that differ fundamentally in their eruptive behaviors and resulting morphologies. The Babylonian text's sophisticated volcanic classification suggests preservation of systematic knowledge about volcanic processes derived from observation or theoretical understanding that far exceeded typical ancient geological knowledge. Research conducted by volcanologist Haraldur Sigurdsson at the University of Rhode Island has documented that ancient Mesopotamian civilizations did maintain detailed records of volcanic activity in surrounding regions, knowledge that may have contributed to the sophisticated volcanic descriptions preserved in creation texts. The text describes valley formation through two distinct mechanisms corresponding precisely to modern geomorphological understanding. The first mechanism involves erosion by flowing water, with the text describing how rivers cut downward into rock and carry away eroded material, gradually carving deep channels through elevated terrain. This description employs terminology indicating awareness that erosional processes operate continuously over extended time periods, with small incremental changes accumulating to produce major landscape modifications. The text specifies that erosional valley formation requires both mechanical cutting by water-transported sediments and chemical dissolution of rock by acidic waters, processes that modern geomorphology recognizes as fundamental mechanisms of fluvial erosion. The second valley formation mechanism described in the tablet involves subsidence, where portions of Earth's surface sink downward due to removal of underlying support. This description corresponds with modern understanding of graben formation and crustal subsidence, processes that create valleys through tectonic activity rather than surface erosion. The Eridu Genesis contains detailed descriptions of the establishment of springs, rivers, and wells as requiring systematic engineering work to organize water flow and distribution across Earth's surface. The text describes Enki drilling deep into the Earth to establish connections with the Abzu and organizing surface water flow to create reliable water sources for future life. These descriptions employ hydraulic engineering terminology that suggests practical understanding of groundwater systems and surface hydrology rather than supernatural water creation. Modern hydrogeology confirms that groundwater systems do require specific geological conditions and connectivity between aquifers and surface features to provide reliable water sources. The Sumerian texts describe the establishment of these hydrological connections as systematic engineering work requiring precision and technical knowledge, suggesting the traditions preserved memories of actual hydraulic infrastructure development rather than miraculous water creation. The consistency of these hydraulic descriptions across multiple texts indicates they represented standardized knowledge about water system establishment rather than independent mythological inventions. The Eridu Genesis fragments describe Enki's establishment of springs as involving identification of geological formations where groundwater naturally approaches the surface and enhancement of these natural discharge points through excavation and channelization. The text employs terminology that distinguishes between different types of springs based on their flow characteristics and water quality, including perennial springs that flow continuously throughout the year, and seasonal springs that flow only during periods of high groundwater levels. This classification system demonstrates sophisticated understanding of groundwater hydrology and the factors controlling spring discharge. Modern hydrogeology recognizes that spring types do differ fundamentally in their hydrological characteristics, based on aquifer properties and recharge patterns. The text's detailed spring classification suggests preservation of systematic hydrological knowledge derived from extensive observation and practical water resource development experience. The text continues by describing Enki's organization of river systems as involving not spontaneous water creation, but systematic channelization of existing water flow to optimize distribution across the landscape. The description employs engineering terminology indicating that river development required excavation of channels following optimal gradients, stabilization of banks to prevent excessive erosion, and construction of diversion structures to distribute water to agricultural areas. These engineering specifications correspond precisely with the hydraulic infrastructure documented at early Mesopotamian sites, where archaeological evidence reveals sophisticated canal systems that appeared suddenly in the historical record with no clear developmental stages. The precision of the hydraulic engineering descriptions suggests the texts preserved technical knowledge about water management systems rather than mythological accounts of miraculous water creation. Research conducted by archaeologist Robert McAdams during surveys of ancient irrigation systems in southern Iraq revealed that the earliest Mesopotamian hydraulic works did incorporate advanced engineering features including optimal channel geometries, sediment management systems, and flow control structures that demonstrated sophisticated understanding of hydraulic principles. The Eridu Genesis describes the establishment of wells as requiring systematic drilling operations to access deep aquifers that would provide reliable water supplies during dry periods. The text employs terminology distinguishing between shallow wells that tap near-surface groundwater and deep wells that penetrate to confined aquifers isolated from surface contamination. This classification demonstrates awareness that groundwater exists in distinct hydrological units with different water quality characteristics and recharge patterns. The text specifies that well construction required not only excavation but also installation of lining materials to prevent collapse and contamination of the water supply. Archaeological evidence from early Mesopotamian sites reveals that ancient wells did incorporate sophisticated construction techniques, including fired brick linings and sealed well heads that protected water quality, confirming the technical sophistication described in creation texts. Analysis conducted by geoarchaeologist Karl Butzer has demonstrated that ancient Mesopotamian water supply systems were remarkably advanced, incorporating multiple redundant sources and sophisticated distribution networks that ensured reliable water availability for urban populations. Tablet BM 92156 describes pre-human Earth as lacking the concentrated mineral deposits and accessible metal ores that would later enable technological civilization. The text states that the gold had not been gathered and the silver had not been collected, that the copper had not been extracted, and the tin had not been mined. These descriptions suggest understanding that accessible mineral deposits resulted from specific geological processes that concentrated valuable materials in locations where they could be extracted and utilized. Modern geology confirms that economically valuable mineral deposits do result from complex geological processes, including hydrothermal activity, sedimentation, a metamorphism that concentrate dispersed elements into accessible deposits. The Sumerian texts describe the formation of these mineral deposits as requiring specific geological conditions and time periods to develop, indicating sophisticated understanding of economic geology. The precision of the mineralogical descriptions suggests the text preserved systematic knowledge of mineral formation processes that far exceeded typical ancient understanding of geology and chemistry. The tablet, preserved in the British Museum's Babylonian collection and discovered during excavations at Sippar, employ systematic nomenclature for different types of mineral deposits that demonstrate sophisticated understanding of ore geology. The text distinguishes between native metals found in pure elemental form and metal-bearing minerals that require smelting to extract usable metals. This fundamental distinction corresponds precisely with modern metallurgical classification, which recognizes that some metals occur naturally in metallic form, while others exist only as chemical compounds that must be reduced through pyrometallurgical or hydrometallurgical processes. The text's emphasis on the absence of gathered gold and collected silver suggests awareness that native metals, while occurring in pure form, still required location and extraction from their geological settings, rather than being freely available at Earth's surface. The tablet continues by describing the formation of copper deposits through hydrothermal processes, employing terminology that indicates understanding of how hot mineral-rich fluids circulate through rock fractures and deposit dissolved metals as they cool. This description corresponds exactly with modern understanding of hydrothermal ore formation, the primary mechanism producing concentrated copper deposits in geological environments. The text specifies that copper deposit formation required specific combinations of heat source, fluid circulation pathways, and chemical conditions that would cause copper to precipitate from solution. Modern economic geology confirms that hydrothermal copper deposits do form through precisely these processes, with magmatic heat driving convective circulation of groundwater through fractured rocks, leaching copper from dispersed sources and concentrating it in favourable chemical and structural settings. The precision of this ore genesis description suggests the Babylonian text preserved sophisticated understanding of hydrothermal processes that would not be formally recognized until the development of modern economic geology in the 19th and 20th centuries. The text describes tin deposits as forming through distinct geological processes involving magmatic differentiation and pneumatolytic activity, using terminology that distinguishes tin ore formation from copper ore genesis. This recognition that different metals form through different geological processes demonstrates sophisticated understanding of ore deposit diversity. The text indicates that tin deposits occur in association with granitic rocks and form during late stages of magmatic crystallization when volatile rich fluids concentrate rare elements including tin. Modern economic geology recognizes this description as corresponding precisely to the characteristics of Greisen and skarn tin deposits, which form through interaction between magmatic fluids and surrounding rocks during late stages of granite crystallization. The Babylonian text's accurate description of tin ore genesis suggests preservation of systematic geological knowledge that far exceeded typical ancient understanding of mineral resources. Research conducted by economic geologist Paul Barton at the United States Geological Survey has demonstrated that ancient metallurgists did possess surprisingly sophisticated understanding of ore deposit characteristics and formation processes, knowledge that enabled them to locate and exploit mineral resources with remarkable efficiency. The Enuma Elish describes the establishment of celestial bodies as a crucial phase in preparing Earth for habitation, specifying that the sun, moon and stars were assigned their proper courses and functions to regulate Earth's environmental conditions. The text presents these celestial assignments not as arbitrary divine decisions, but as systematic engineering required to establish stable climatic and seasonal patterns. Modern astronomy confirms that Earth's environmental stability does depend on regular celestial movements and gravitational interactions within the solar system. The Babylonian text describes the coordination of multiple celestial bodies to create optimal conditions for life, suggesting sophisticated understanding of astronomical factors affecting planetary habitability. The precision of the astronomical descriptions indicates knowledge of celestial mechanics that far exceeded typical ancient understanding of planetary motion and gravitational forces. The texts specify that proper coordination of celestial movements required precise calculations and adjustments, suggesting awareness that planetary habitability depends on specific astronomical configurations. The astronomical sections of the Enuma Elish, preserved primarily on Tablet 5 of the 7-tablet series, provide detailed specifications for the establishment of celestial bodies and their functions in regulating Earth's environment. The text describes the sun as being assigned the primary role of providing heat and light necessary for life, with specific instructions regarding its daily path across the sky and its seasonal variations in position. The description employs astronomical terminology, indicating awareness that the sun's apparent motion results from Earth's rotation and orbital movement rather than actual solar motion. This heliocentric understanding, centuries before its official recognition by Copernicus, suggests the Babylonian text preserves sophisticated astronomical knowledge that contradicted the geocentric models that would dominate Western astronomy until the Renaissance. The text specifies that the sun's intensity had to be calibrated to provide optimal heating, avoiding excessive temperatures that would desiccate the surface while providing sufficient energy to drive atmospheric circulation and support photosynthesis. The text continues by describing the moon's role in regulating tidal cycles and providing nighttime illumination. The description demonstrates awareness that lunar phases result from changing geometric relationships between sun, moon and Earth as the moon orbits Earth. The text specifies that the moon's orbital period of approximately 29½ days produces the regular cycle of phases that would serve as basis for calendar systems. Modern astronomy confirms that the synodic lunar month does last approximately 29.53 days, matching precisely the duration specified in the Babylonian text. The description continues by noting the moon's influence on ocean tides, employing terminology suggesting understanding of gravitational tidal forces. This recognition of lunar tidal effects demonstrates sophisticated astronomical knowledge, as tidal mechanisms would not be formally explained until Isaac Newton developed the law of universal gravitation in the 17th century. Research conducted by astronomer John Steele at Brown University has revealed that Babylonian astronomers possessed remarkably accurate knowledge of lunar motion and its effects on Earth, knowledge preserved in astronomical texts spanning many centuries. The Enuma Elish describes the establishment of stars as serving multiple functions, including navigation aids, seasonal markers, and regulators of long-term cycles. The text indicates that stars were positioned in specific configurations that would enable humans to determine directions, track seasonal changes, and predict astronomical phenomena. This functional description of stellar positions suggests understanding that star patterns served practical purposes rather than merely decorative roles. The text specifies that certain stars are assigned to mark important seasonal transitions, including solstices and equinoxes, celestial events that determine agricultural timing and climate patterns. Modern astronomy recognizes that heliacal risings and settings of specific stars do serve as reliable seasonal markers, with particular stellar appearances corresponding to specific times of year. The precision of the Babylonian stellar calendar system suggests the text preserves sophisticated astronomical knowledge derived from centuries of systematic observation and mathematical analysis. Tablet CBS 18765 describes the preparation of Earth's soil as requiring systematic modification of raw geological materials through biological and chemical processes. The text states that the soil had to be made fertile and the earth had to be prepared for planting. Employing agricultural terminology that distinguishes between different soil types and conditions, these descriptions suggest understanding that agricultural soil results from complex processes involving weathering of rocks, accumulation of organic material, and biological activity that transforms raw mineral material into medium capable of supporting plant growth. Modern soil science confirms that agricultural soil formation does require these complex processes operating over extended time periods. The Sumerian text describes soil preparation as systematic work, requiring knowledge of biological and chemical processes, suggesting the traditions preserved understanding of agricultural science that preceded formal soil chemistry by millennia. The precision of the agricultural descriptions indicates the texts preserved practical knowledge about soil development rather than mythological speculation about Earth creation. The tablet, discovered during University of Pennsylvania excavations at Nippur and currently housed in the University Museum's Babylonian collection, employs systematic classification of soil types based on their physical and chemical properties. The text distinguishes between sandy soils with large particle sizes and poor water retention, clay soils with fine particles and excellent water retention but poor drainage, and loamy soils with intermediate properties optimal for agriculture. This classification system corresponds precisely with modern soil texture classification, which categorizes soils according to the proportions of sand, silt, and clay particles they contain. The text indicates that optimal agricultural soils required balanced mixtures of different particle sizes that would provide adequate drainage while retaining sufficient moisture and nutrients. Modern soil science confirms that loamy soils with balanced sand-silt-clay ratios do provide optimal physical conditions for plant growth, validating the agricultural knowledge preserved in the Sumerian text. The tablet continues by describing chemical soil preparation processes, including addition of organic materials to enhance fertility and modification of soil acidity to optimize nutrient availability. The text employs terminology indicating awareness that plant growth requires specific chemical nutrients that must be present in appropriate forms and concentrations. The description specifies that organic materials, including plant residues and animal wastes, had to be incorporated into soil to provide essential nutrients and improve soil structure. Modern soil chemistry confirms that organic matter does provide crucial benefits, including nutrient supply, improved water retention, enhanced microbial activity, and better soil aggregation. The Sumerian text's emphasis on organic amendments demonstrates sophisticated understanding of soil fertility management that preceded formal agricultural chemistry by millennia. Research conducted by agricultural historian Thorkild Jacobsen has revealed that early Mesopotamian farmers did practice systematic soil management, including organic amendments, crop rotations, and fallow periods that maintained soil fertility across multiple growing seasons. Techniques that match precisely the soil preparation procedures described in creation texts. The text describes biological soil preparation processes including encouragement of earthworm activity and promotion of beneficial microorganisms that would enhance soil fertility and structure. The description employs terminology indicating awareness that soil contains living organisms that perform essential functions including organic matter decomposition, nutrient cycling, and soil aggregation. This recognition of soil biological activity demonstrates remarkably sophisticated understanding of soil ecology that would not be formally recognized until the development of soil microbiology in the 19th and 20th centuries. The text specifies that proper soil preparation required time for biological processes to transform raw mineral materials into fertile growing medium, indicating awareness that soil development involves complex interactions between physical and chemical and biological factors operating over extended periods. Modern soil science confirms that soil formation is indeed a slow process requiring decades to centuries for development of productive agricultural soils from raw parent materials. The creation texts describe the establishment of geographical boundaries and territorial divisions as fundamental phase in organizing Earth for habitation. Tablet K 19,876 states that the borders had not been established and the territories had not been assigned, suggesting understanding that geographical organization represented systematic planning rather than natural condition. The text continues by describing how divine beings surveyed the land and established boundaries based on geographical features and resource distribution. These descriptions employ surveying and administrative terminology that suggests practical understanding of land management rather than mythological territory creation. Archaeological evidence from early Mesopotamian sites reveals sophisticated surveying capabilities and land management systems that appeared suddenly in the historical record, suggesting transmission of advanced knowledge that the creation texts attribute to divine instruction. The consistency of boundary establishment descriptions across multiple texts indicates they represented standardized procedures for territorial organization rather than independent mythological inventions. The tablet, discovered during excavations at Nineveh and currently preserved in the British Museum's Assyrian collection, provides detailed descriptions of surveying procedures used to establish territorial boundaries. The text describes divine surveyors using measuring rods and sighting instruments to determine precise distances and angles, employing technical terminology that corresponds with actual surveying equipment documented in archaeological contexts. The description specifies that boundaries were established along natural features, including rivers, mountain ridges, and geological formations that provided clear demarcation between adjacent territories. This practical approach to boundary definition corresponds with documented ancient land management practices, where natural features served as permanent and easily recognizable territorial markers. The text indicates that where natural boundaries were absent, artificial markers including stone pillars and earthen mounds were constructed to define territorial limits. Archaeological surveys throughout Mesopotamia have revealed ancient boundary markers that match precisely the descriptions found in creation texts, confirming the practical nature of these territorial establishment procedures. The tablet continues by describing how territories were assigned based on systematic evaluation of resources, including water availability, soil fertility, mineral deposits, and strategic positioning. The text employs administrative terminology, indicating that territorial allocation followed rational criteria designed to ensure equitable distribution of essential resources. This systematic approach to land division demonstrates sophisticated understanding of resource management and territorial administration. The description specifies that each territory was surveyed to determine its productive capacity and resource endowments, with boundaries adjusted to ensure that territorial units contained balanced combinations of different resource types. Modern administrative geography recognizes that effective territorial organization does require consideration of resource distribution and accessibility, validating the rational planning approach described in the Sumerian texts. Research conducted by geographer Robert McAdams during studies of ancient Mesopotamian settlement patterns revealed that territorial divisions in early Sumerian city-states did follow systematic principles that optimized resource access and administrative efficiency, matching closely the planning procedures described in creation texts. The text describes the establishment of boundary maintenance systems, including regular surveys to verify marker positions and legal procedures for resolving territorial disputes. The description employs legal terminology, indicating that boundary establishment was not merely initial surveying, but involved ongoing administration to maintain territorial integrity. This recognition that boundaries required continuous maintenance demonstrates sophisticated understanding of land administration challenges. The text specifies that boundary markers had to be inspected regularly and repaired when damaged, with precise records maintained of marker positions and territorial extents. Archaeological evidence from early Mesopotamian sites reveals extensive administrative archives documenting land surveys, boundary descriptions, and dispute resolutions, confirming the sophisticated land management systems described in creation texts. Analysis conducted by legal historian Martha Roth at the Oriental Institute has demonstrated that ancient Mesopotamian boundary law was remarkably advanced, incorporating principles of surveying accuracy, documentary evidence, and dispute resolution that anticipate modern cadastral systems. Tablet V AT 23412 describes pre-human Earth as existing without language or communication systems, stating that no word had been named and no speech had been established. This description presents language not as inherent human capability, but as systematic development that required specific conditions and instruction to establish. The Sumerian texts describe the establishment of language as requiring divine instruction and the assignment of proper names to all things in creation. Modern linguistics recognizes that language development does involve systematic naming processes and the establishment of symbolic systems for communication. The precision of the linguistic descriptions in the creation texts suggests sophisticated understanding of language structure and development that preceded formal linguistics by millennia. The texts specify that language establishment required organizing sounds into meaningful patterns and creating systematic relationships between words and concepts, indicating awareness of linguistic principles that would not be formally recognized until modern structural linguistics. The tablet, housed in the Vorderasiatisches Museum in Berlin and discovered during German excavations at Uruk, employs terminology that distinguishes between different aspects of language development, including phonology, vocabulary, and grammar. The text describes the establishment of speech sounds as requiring systematic organization of vocal articulations into distinct phonemes that could be combined to form meaningful words. This recognition that languages consist of discrete sound units demonstrates sophisticated phonological awareness. The description specifies that sound systems were designed to maximize distinctiveness between phonemes while remaining within the articulatory capabilities of human vocal anatomy. Modern phonology confirms that language sound systems do balance these competing constraints, selecting phoneme inventories that provide adequate communicative capacity while avoiding sounds that are difficult to produce or perceive. The Sumerian text's awareness of these phonological design principles suggests preservation of systematic linguistic knowledge that preceded formal phonology by millennia. The tablet continues by describing the establishment of vocabulary through systematic naming of all entities and phenomena in creation. The text employs terminology indicating that naming was not arbitrary, but followed logical principles that reflected the nature and relationships of named entities. This description suggests understanding that vocabulary constitutes systematic symbolic mapping between linguistic forms and conceptual meanings. The text specifies that names were assigned in hierarchical fashion, with general categories named first, followed by progressive subdivision into more specific categories. This taxonomic approach to vocabulary development demonstrates sophisticated understanding of semantic organization. Modern lexical semantics recognizes that vocabulary does exhibit hierarchical structure, with general terms subsuming more specific terms in systematic relationships. The Sumerian text's description of systematic vocabulary development suggests preservation of linguistic knowledge. About semantic organization principles. Research conducted by linguist John Hunegard at the University of Texas has revealed that Sumerian and Akkadian vocabulary systems do show evidence of systematic organization based on semantic categories and hierarchical relationships, validating the structured vocabulary development described in creation texts. The text describes the establishment of grammar as requiring systematic organization of words into structured sequences that convey complex meanings through their arrangements and relationships. The description employs terminology indicating awareness that language involves not merely vocabulary, but also structural principles that govern how words combine to form meaningful utterances. This recognition of grammatical structure demonstrates sophisticated linguistic awareness. The text specifies that grammar included rules for word order, case marking, verb conjugation, and agreement systems that would enable precise expression of complex relationships. Modern syntax recognizes these as fundamental components of grammatical systems that enable languages to express unlimited meanings through finite means. The Sumerian text's detailed description of grammatical components suggests preservation of systematic linguistic knowledge about language structure. The text indicates that grammatical systems were designed to balance expressiveness with learnability, incorporating sufficient complexity to enable precise communication, while remaining simple enough for humans to acquire and use effectively. This recognition of competing design pressures in grammatical systems demonstrates remarkably sophisticated understanding of linguistic theory. Administrative texts from Babylon describe the preparation of Earth as involving construction of dwelling places suitable for divine beings to inhabit during their earthly missions. Tablet BM 45,000. 789 states that the first structures built on Earth were temples and sacred precincts designed to house divine beings and provide them with appropriate facilities for conducting their work. These descriptions employ architectural terminology that suggests practical construction procedures rather than supernatural temple manifestation. Archaeological evidence from the earliest temple sites reveals sophisticated construction techniques that appear suddenly in the archaeological record without clear developmental stages. The Sumerian texts describe these early temples as incorporating specific design features required for divine comfort and operational needs, suggesting the traditions preserved memories of actual construction projects rather than mythological temple creation. The consistency of temple construction descriptions across multiple texts indicates they represented standardized architectural procedures rather than independent mythological inventions. The tablet, preserved in the British Museum's Babylonian collection and discovered during excavations at Babylon by Robert Calderway between 1899 and 1917, provides detailed architectural specifications for early temple construction. The text describes temple layouts, including central sanctuaries for divine habitation, subsidiary chambers for ritual activities, storage facilities for supplies and equipment, and courtyards for assemblies and ceremonies. These architectural components correspond precisely with temple layouts documented at the earliest Mesopotamian sites, confirming the practical nature of the construction descriptions. The text employs technical terminology describing foundation preparation, wall construction, roof installation, and interior finishing that demonstrates sophisticated architectural knowledge. The description specifies that foundations had to be excavated to stable substrata and filled with compacted materials that would distribute structural loads and prevent differential settlement. Modern structural engineering recognizes these as fundamental principles of foundation design, validating the sophisticated construction knowledge preserved in creation texts. The tablet continues by describing specific design features incorporated into early temples to meet operational requirements of divine inhabitants. The text indicates that temples included ventilation systems to maintain comfortable interior temperatures, water supply systems to provide fresh water for ritual and domestic uses, and drainage systems to remove wastewater and prevent flooding. These infrastructure systems demonstrate sophisticated understanding of building services and environmental control. Archaeological evidence from early temple sites reveals extensive infrastructure installations, including underground channels for water supply and drainage, ventilation shafts that maintain air circulation, and climate control features that moderate interior temperatures. Analysis conducted by archaeologist Harriet Crawford at University College London has revealed that Mesopotamian temple architecture incorporated remarkably advanced environmental control systems that enabled comfortable habitation in the harsh Mesopotamian climate, confirming the sophisticated building services described in creation texts. The text describes construction materials including fired bricks for structural walls, bitumen for waterproofing, cedar timber for roof beams, and precious stones for decorative elements. The description employs terminology distinguishing between different material grades and specifying appropriate applications for each material type. This systematic approach to material selection demonstrates sophisticated understanding of construction technology and material properties. The text indicates that material specifications were not arbitrary, but were based on functional requirements including structural strength, durability, water resistance, and thermal properties. Modern materials engineering recognizes that effective construction does require systematic material selection based on performance requirements and environmental conditions. The Sumerian text's detailed material specifications suggest preservation of advanced construction knowledge that enabled early civilizations to build durable structures in challenging environmental conditions. Research conducted by material scientist Pamela Van Dever at the Smithsonian Institution has demonstrated that ancient Mesopotamian construction materials were remarkably sophisticated, incorporating carefully controlled manufacturing processes and quality control procedures that produce consistent high-quality materials. The Atrahasis Epic describes an extended period of testing and adjustment during which divine beings evaluated Earth's readiness for human habitation and made necessary modifications to environmental systems. The text indicates that this testing period involved systematic monitoring of atmospheric conditions, water systems, soil quality, and other factors that would affect human survival and comfort. These descriptions employ technical terminology, suggesting systematic evaluation procedures rather than arbitrary divine inspection. Modern planetary science recognizes that determining planetary habitability does require comprehensive evaluation of multiple environmental factors and their interactions. The Babylonian text describes specific adjustments made during this testing period to optimize conditions for human life, including modifications to atmospheric composition, adjustment of water distribution systems, and enhancement of soil fertility. The precision of these descriptions suggests the text preserved systematic understanding of environmental engineering rather than mythological speculation about Earth preparation. The Atrahasis Epic, preserved in multiple versions including copies from the Old Babylonian period around 1700 BC and later Assyrian versions from the Library of Ashurbanipal, describes the testing period as lasting 40 years during which divine beings conducted systematic environmental monitoring. The text employs chronological precision rather than vague mythological time, suggesting the description preserved traditions about actual historical periods. The description indicates that monitoring involved regular sampling and measurement of environmental parameters, including atmospheric pressure and composition, water quality and availability, soil fertility and structure, and temperature ranges throughout seasonal cycles. This systematic monitoring approach corresponds with modern environmental assessment methodologies that require comprehensive data collection over extended periods to characterize baseline conditions and identify potential problems. The Babylonian text's emphasis on systematic monitoring demonstrates sophisticated understanding of the information requirements for environmental management decisions. The epic continues by describing specific environmental adjustments made based on monitoring results. The text indicates that atmospheric composition required modification to increase oxygen concentration and reduce levels of gases that would be toxic to human respiratory systems. This description corresponds with scientific understanding that Earth's atmosphere did undergo significant compositional changes through geological and biological processes that transformed it into a life-supporting medium. The text specifies that these atmospheric modifications required careful calibration to achieve optimal oxygen levels that would support aerobic respiration while avoiding oxygen, concentrations high enough to increase fire risk. Modern atmospheric science recognizes that Earth's current oxygen concentration of approximately 21% does represent an optimal balance that supports complex life while maintaining acceptable fire safety. Validating the calibration principles described in the Babylonian text, research conducted by geochemist James Casting has demonstrated that atmospheric oxygen levels are indeed critical for planetary habitability and that Earth's oxygen concentration appears to be maintained within narrow bounds that optimize conditions for complex life. The text describes adjustments to water distribution systems to ensure reliable water availability across diverse geographical regions and throughout seasonal cycles. The description indicates that modifications included enhancement of groundwater recharge, stabilization of spring discharge, regularization of river flow patterns, and establishment of precipitation patterns that would provide adequate moisture without excessive flooding. These hydrological modifications demonstrate sophisticated understanding of water cycle components and their management. The text specifies that water distribution adjustments required coordination between atmospheric processes controlling precipitation and geological structures controlling groundwater storage and flow. Modern hydrology recognizes that sustainable water systems do require integration of surface water and groundwater components with atmospheric moisture sources. The Babylonian text's recognition of these hydrological interconnections suggests preservation of systematic understanding of water cycle dynamics that preceded formal hydrology by millennia. The creation texts culminate in descriptions of the divine decision to create humans as final phase in Earth's preparation for habitation. Tablet CBS 29847 describes a council session where divine beings evaluated whether Earth had reached suitable condition for introducing human populations. The text employs deliberative language suggesting systematic decision-making process based on specific criteria rather than arbitrary divine whim. The creation narratives specify that humans were created to serve specific functions, maintaining Earth systems and conducting agricultural work that would sustain both human and divine populations. These functional descriptions suggest the texts preserved traditions about actual labor requirements and population management rather than theological speculation about human purpose. The precision of the decision-making descriptions indicates the text's preserved systematic understanding of the considerations involved in introducing new species to established ecosystems. The texts specify that human creation required careful planning to ensure the new species would be capable of surviving in Earth conditions while fulfilling intended functions. The tablet, discovered during University of Pennsylvania expeditions to Nippur and housed in the University Museum's Babylonian collection, describes the Divine Council session as involving systematic presentation of environmental assessment data, followed by deliberative evaluation of whether conditions met established criteria for human introduction. The text employs administrative terminology suggesting formal decision-making procedures rather than arbitrary divine declarations. The description indicates that multiple divine beings participated in the decision process, presenting different perspectives and evaluating various factors relevant to human creation. This deliberative framework suggests the text preserved traditions about actual planning sessions, rather than theological speculation about divine decision-making. The text specifies that the decision to create humans was not made lightly, but required careful consideration of potential risks and benefits associated with introducing new intelligent species to Earth's established ecosystems. The tablet describes specific criteria evaluated during the decision process, including atmospheric composition suitable for human respiration, temperature ranges compatible with human physiology, water availability sufficient for human populations, food sources adequate for human nutrition, and absence of environmental hazards that would threaten human survival. These evaluation criteria demonstrate sophisticated understanding of the environmental requirements for human habitability. The text indicates that all criteria had to be met simultaneously for human creation to proceed, recognizing that habitability depends on multiple factors operating together rather than single environmental parameter. Modern astrobiology employs similar multi-factor approaches to evaluating planetary habitability, assessing combinations of atmospheric, thermal, hydrological, and chemical conditions that would permit life. The Babylonian text's systematic habitat evaluation framework anticipates modern astrobiology methods by millennia, suggesting preservation of sophisticated understanding of habitability requirements. The text continues by describing the functional purposes for which humans would be created, specifying that human populations would perform agricultural work to produce food, maintain irrigation systems to distribute water, conduct mining operations to extract minerals, and perform construction activities to build structures. These functional specifications demonstrate practical understanding of the labour requirements for maintaining civilized societies. The text indicates that humans were specifically designed to be capable of performing these functions through incorporation of appropriate physical capabilities and intellectual capacities. This functional design approach suggests the text preserved traditions about actual workforce planning rather than theological speculation about human nature. The description specifies that human capabilities had to be calibrated carefully to enable performance of required tasks while maintaining dependence on divine guidance and preventing humans from developing excessive independence that might threaten established order. This recognition of competing design objectives in human creation demonstrates sophisticated understanding of the challenges involved in creating capable but controllable workforce populations. The precision of these functional descriptions suggests the creation texts preserve genuine traditions about actual planning processes that preceded human introduction to Earth, rather than purely imaginative mythology about human origins. The evidence presented throughout this investigation reveals that Sumerian creation texts preserved far more than religious mythology or primitive speculation about Earth's origins. These ancient documents demonstrate sophisticated understanding of planetary formation processes, atmospheric evolution, geological mechanisms, hydrological systems, and biological development that preceded modern scientific discovery by millennia. The precision of geological descriptions, including sedimentary accumulation, volcanic activity, and tectonic processes, corresponds exactly with modern understanding of Earth's topographical development. The detailed atmospheric accounts describing compositional changes, pressure variations, and the establishment of stable circulation patterns match current knowledge of planetary atmosphere evolution. The systematic botanical and zoological classifications reflecting sequential appearance of different life forms parallel the actual progression documented through paleontological research. The consistency of these technical descriptions across multiple independent sources spanning different periods and geographical locations argues powerfully against dismissing them as coincidental inventions or poetic metaphors. The text employs specialized technical terminology for geological processes, chemical compositions, astronomical phenomena, and engineering procedures that demonstrate access to systematic knowledge far exceeding typical ancient understanding. The precision of measurements, the accuracy of process descriptions, and the sophistication of theoretical frameworks preserved in these texts suggest they derived from advanced knowledge systems that were transmitted through carefully maintained textual traditions. The implications of this preserved knowledge extend far beyond academic curiosity about ancient scientific understanding. These texts suggest that human civilization has access to information about Earth's developmental history that was obtained through methods and during periods not adequately explained by conventional historical models. The sudden appearance of sophisticated knowledge in early Mesopotamian civilization without clear developmental stages parallels the pattern found in other domains, including advanced astronomical calculations, complex mathematical systems, and sophisticated engineering capabilities. This pattern suggests that early civilizations inherited, rather than independently developed their foundational knowledge systems. The creation texts themselves provide framework for understanding this knowledge transmission through their consistent descriptions of divine beings who prepared Earth for human habitation and instructed early humans in essential technologies and sciences. Whether these divine beings represented advanced prehistoric civilizations, extraterrestrial visitors, or other sources of knowledge transmission, the texts clearly indicate that early Mesopotamian civilizations understood themselves as recipients of inherited wisdom rather than original discoverers of the knowledge they possessed. The systematic nature of this transmitted knowledge and its preservation through multiple textual traditions demonstrates that ancient societies developed sophisticated methods for maintaining and transmitting essential information across generations and through periods of cultural disruption. For contemporary humanity facing challenges of environmental degradation, resource depletion, and technological risks, the ancient understanding that planetary habitability requires careful maintenance of integrated environmental systems takes on renewed significance. The creation text emphasized that Earth's life-supporting characteristics resulted from systematic preparation and calibration of multiple interconnected systems operating according to precise physical principles. This recognition that habitability represents achievement rather than inherent condition suggests that maintaining Earth's environmental stability requires active stewardship informed by comprehensive understanding of planetary systems. The knowledge preserved in these ancient texts may provide crucial insights for addressing contemporary environmental challenges and ensuring the continued habitability of our planet for future generations. The systematic approach to environmental management described in creation texts offers frameworks for understanding Earth system dynamics that complement and potentially enhance modern scientific approaches to planetary stewardship.